14.3 is sum and difference angles, more trig identities for us to play with, things that I know that we love. If you have the sine of two angles being added together, like say I took an angle A and an angle B, and I added them up before I calculated their sine, that actually follows a formula, sine A cosine B plus cosine A sine B, where these two are being multiplied and these two are being multiplied. There's a sum and a difference formula for both sine, cosine, and tangent for all three of them, so there's 6 total, one for each. And they all have the same sort of form. Basically, the pluses and the minuses are always just switching with the way these are arranged. Minuses become pluses and pluses become minuses in your sum and difference formulas. Now, it's important to understand that, like, if I was doing the sine of 30 plus 50, I cannot try to make that sine 30 plus sine 50. That's not how that works. I don't like to distribute that sign or anything. That's why we need to have these properties. If I want to do the sine of 30 plus 50, I would do the sine of 30 cosine 50 plus cosine 30 sine 50. And that just came from this formula right here, where my A value is 30 and my B value is 50. Now, sine of 80 isn't one we would figure this way most likely. I suppose we could if we really wanted to, but we don't need to. Ones that are more useful are things like the cosine of 105. Well, the cosine of 105, that's 105 isn't on my unit circle. Over here, 105 would be like somewhere in this range, but there is no 105 in the unit circle. So what I can do is take 105 and make it a combination of two things that are on the unit circle. 60 and 45. Well, then I'm going to follow this formula. So I'm going to do, it's like this is my A and this is my B, and I'll do, I'm following this formula here. Cosine A, cosine B, so cosine 60, cosine 45, minus sine A, sine B, so sine 60, sine 45. Well, the cosine of 60 I know, the cosine of 60 is a half. The cosine of 45 is root 2 over 2. The sine of 60 is root 3 over 2. And the sine of 45 is also root 2 over 2. So I end up getting root 2 over 4 minus root 6 over 4, and we just leave that root 2 minus root 6 over 4. And that's the exact value. Whenever it says exact value for anything in trig, it pretty much means you're going to be on the unit circle. So if I'm going to do the sine of 15 degrees, well, again, 15 degrees isn't on the unit circle, but I could do 30 minus 45. That is on the unit circle. And when I'm doing sine, and again, it's like this is my A and this is my B, the sine, it's a difference formula. I'm doing this one here, sine of A minus B, sine A cosine B minus cosine A sine B. So it's sine A cosine B, that's a positive 45, because my B value here is positive, sine A cosine B minus cosine A sine B, so minus cosine 30 sine 45. I'm going to jump over to one screen now so I can see this a little bit better. Everything kind of blows up in size. I'll pull this all over here a little bit. Sine 30 is 1/2. Cosine 45 is root 2 over 2. Cosine 30 is root 3 over 2. Sine 45 is root 2 over 2. And I end up getting root 2 minus root 6 over 4. You get a lot of root 2s and root 6s and 4s actually. In this case we got the same thing. Their order can flip, and it's not always root 6s and 2s, but they do come up a lot. Cosine 195. Well, how am I going to get to 195? I could do 135 and 60. I could do 225 minus 30. One of those would be a sum, and one of those would be a difference angle. Doesn't really matter which one you pick. There's probably a bunch of ways for me to get to cosine of 95. I've already done a cosine addition, so I'll do a cosine subtraction just to keep it kind of interesting. I'll do this one. I knew here it was a minus. This had a minus. So my new one's going to have a plus. The sign's just going to switch on it. So it's going to be cosine 225 cosine 30 plus sine 225 sine 30. I'm going to take a second and just make sure I wrote that down correctly. I'm doing cosine A minus cosine B, so it's cosine A cosine B plus sine A sine B, and that's exactly what I did. Cosine 225 is negative root 2 over 2. Cosine 30 is root 3 over 2. Sine 225 is negative root 2 over 2. Sine 30 is 1/2. And here's a negative root 6 plus root 2 over 4. So there's some basic computations you can do. Those shouldn't take you too long on your homework. The other thing you can do is more verifying, more proofs. I'm going to prove or show that cosine of 90 plus x is the same as negative sine x. Well, this is a sum of a and b. So I'm going to go to my sum. So it's cosine a cosine b minus sine a sine b. I'm just doing this one here. In this case, that's my a and that's my b, so I'm really doing cosine 90 cosine x minus sine 90 sine x. What happens really often here is one of them goes away. The cosine of 90 is 0. On the unit circle, the cosine of 90 is 0. So this becomes 0 times the cosine of x, which is just 0. The sine of 90 is 1. And we're left with just negative sine x. So the verifying is pretty straightforward. Cosine of 180 minus x equals cosine x. Well, this is going to be cosine a cosine b plus sine a sine b, where that's my a and that's my b. So it's cosine 180 cosine x plus sine 180 sine x. Cosine of 180 is negative 1. Sine of 180 is 0. And you just get negative cosine x, which is there. We didn't do any tangent in this video. It's nothing really new or different about it. You just follow the tangent formulas, which have some fractions in them, but they really aren't too bad once you get going. I don't think there's much tangent in your homework. And that takes care of 14.3. Thank you very much.